Hello, today I will show you a demonstration of Kapitza pendulum. So all of you know about the simple pendulum, and simple pendulum has two equilibriums. So one of them is here, that theta is equals to 0. You can see that it is oscillating around its equilibrium position, theta equals to 0. If you just part of the system, then it will try to come back to its equilibrium position. uh, but if you just put it just theta is equals to pi, which is like this, so you can see that if you part of the system, then it will go away from its equilibrium and it is oscillating in different way. So from here you can see that this is actually the unstable equilibrium. The theta is equals to 0 was the stable equilibrium, but the theta is equals to pi is the unstable equilibrium. But you can make it stable. You can make it stable by give an oscillation to its base. And if your base, the not your base but the pendulum's base, if the pendulum's base is oscillate with can oscillate with some amplitude and some high frequency. Okay, so for me, I have put this amplitude is equals to 5, and I put the frequency, maybe let's put it 10. It is oscillating slowly, but it is not stable. Okay, but we try again. Let me see that it is getting stable or not. No, it is not getting stable. So now just let me make it 30. This is faster, but still it is not if I just put again, just oh, it's getting stable, but I don't think it will be stable. No, it is getting towards the another fixed point. But now let me just make it 50, and yeah, just it is the pi position, and I have part out, but now it is not going away. Okay, it is not falling down, and you can see that this is stable with high frequency. So if your base is the pendulum's base is oscillating with a high frequency, then it is getting stable, and here you can see that it is stable. So this is the basic thing in Kapitza pendulum. So thank you, and please subscribe and share.